Okay, here we go with the solutions to homework sheet 16. Question 1. We have a quadratic x squared minus 5x plus k plus 6 is equal to 0, and you have to find the value of k for equal roots. So for equal roots we need to identify what the value of a, b and c are. So a is a number before x squared, b is a number before x, and c is basically everything else. And then for equal roots, we know the situation that needs to be the case is the discriminant b squared minus 4ac has to equal 0. So plugging these values in, minus 5 squared take away 4 times 1 times k add 6 has got to be 0. 25 minus 4k minus 24 is 0. 4k must be 1, so k must be a quarter. Question 2. Complete the square. Inside the bracket, x plus 1 squared. This bracket gives us an extra 1 squared, which is 1. We need to get to negative 8 or take away 8, so therefore we need to minus 9. Question 3. Prove that these 3 points are collinear. So a to b, that's little b minus little a, which for our example comes out to be 693, which I can write as 3 lots of 2, 3, 1. Then we can work out b to c, which is little c minus b, which for our example comes out to be 8, 12, 4, which taking 4 out as a factor leaves us 2, 3, 1. Now moving the 4 over here and the 3 over here gives us that 4 a to b is the same as 3 b to c, or a to b is equal to 3/4 b to c. That tells us that they're parallel, and as b is a common point, that tells us that they're collinear with the ratio 3 to 4. For part B, we have to prove that DB is perpendicular to AB. Now we know AB, we've just worked it out from the first part of the question. It's 693. We need to work out what DB is. So DB is little b minus little d, which for this example comes out to be minus 3, 3 and minus 3. Now for perpendicular vectors, we know that when we do the dot product between them, we should get 0 coming out. So what we now need to do is take the 6 and multiply it by the negative 3 to give us negative 18. Then 9 and multiply it by the 3 to give us 27. And then last 3 multiplying the negative 3 giving us negative 9. Add all these together, negative 27 add 27, which means 0 is in fact 0, as you would hope it to be, so that proves that they're perpendicular. For question 4, we have this curve here. We know that it passes through this point here, A0, and this point here, which is 8b. Every single log curve, you know, passes through the point 1, so that means that A has the value 1. Secondly, because we know it passes through this point, if I substitute that point into that formula, we should be able to work out what B is. So B is, in place of y, log to the base 2 of 8, log to the base 2 of 2 cubed, because 2 cubed is 8. That means the 3 can come down the front, So b is 3 log to the base 2 of 2, which is 3. Because once we get the base number and the other number the same, then we know that equals 1. So the answer to the question is that a is worth 1 and b is worth 3. Second part, sketch the graph of y equals log to the base 2 of x plus 1 minus 3. What does that mean? The plus 1 means that we move the graph left 1. The minus 3 means we move the graph down 3. So, the graph which started here gets moved to here and then eventually gets moved down here. So let me take all of these out and put on the finishing graph. So the finishing graph looks something like this. Change the colour. Something like this. This point here is 3. Now we know that it started at the point 8,1. It was moved left 1, 8,3. It was moved left 1, which becomes 7,3, and then down 3. Then this point here must be 7. Also remember, when you draw these graphs, if the asymptote moves, then you need to move it as well. So the graph should look something similar to what I've got here, going through the points minus 3 and 7. Question 5, to find the equation of a straight line which is parallel to the one I've given here. So the first thing I need to do is rewrite it as 3y equals negative 2x add 5, y equals negative 2 over 3x add 5 over 3. Now the over 3 part at the end I'm not really interested in, because this is what I'm looking for. I need to find the gradient. So the gradient is negative 2/3. We know the question says it's to go through the point 2 minus 1. That should be enough information for us to actually work out its equation. Y minus negative 1 equals negative 2 over 3 x minus 2. Remember what we do here. Take the 3 from the bottom to multiply this side. Take the negative 2 to multiply this side. So we get 3y plus 3 equals negative 2x plus 4. Rewriting it, 3y plus 2x equals 1. Question 6, some differentiation. dy by dx, bring down the power, decrease by 1, bring down the power, decrease by 1. Second one, first thing we need to do here is we need to write that as 3 over 4 and then get the x up to the top. Now we can differentiate it, bring down the power, negative 3/4, decrease the power by 1, and if I want to rewrite that with a positive power, negative 3 over 4, and that x would go back down the bottom as x squared. The last part of that question, y equals the square root of x, again get it in a form where we can actually differentiate. We know that square root means x to the power of half, so the gradient function, bring down the power, decrease the power by 1. If I want to write it back with a positive power, it'll be 1 over 2 x to the power of half, and if I wanted to put the root signs back in, 1 over 2 root x. Question 7. I think we've seen this one before. The man who borrows the interest. Well, if the interest is calculated at 1.5%, then that means the amount is due is 100 plus the 1.5%, which is 101.5%, which as a multiplier, that comes out to be 1.015. So your recurrence relation is the amount of money that is due back is 1.105 of the amount that is due at the end of the month less the £300 he's paying back, with a starting value U0 of £2,500. Okay, now the second part of the question, what's his repayments and how much is the final one? He borrows the money on the 2nd of May, so on the 2nd of May he's owing back £2,500. On the 1st of June, and a month's time, his interest has gone up by 1.5%, but he's paid back £300. So that means he's due to pay back £2,237.50. Now on your calculator, the best way to do this question is to put the 2,500 in, press equals, and then type in your reconciliation 1.015 times, and use the answer key, minus 300. And if you keep doing that and that and that, you'll hopefully find out that when it gets to the 1st of January, he's actually due £286. Okay, and then at the end of the month, he's had 1.5% added on to that. So on the 31st of January, he's due £290.68. So his final payment on the 1st of February is indeed £290.68. You get all that from your calculator. Question 8. We have a circle which is centred on the origin, 0, 0. And we're trying to find the equation of the tangent, that's not a very good tangent, but you know what I mean, at the point 1 minus 3. How do we do that? The stages we go through, first of all, is find the gradient of the radius. So that's negative 3 minus 0 over 1 minus 0, which is negative 3. Then we get the gradient of the tangent, which we know is perpendicular to that, so that's a third. Because we know that it passes through the point 1, negative 3, we can write down its equation as y minus negative 3 equals 1/3 x minus 1. Same as the previous example, this 3 goes over there, multiplies, this 1 stays here and multiplies. So 3y plus 9 equals x minus 1, which gives us 3y plus 10 equals x, or rewriting it, x equals 3y plus 10 in the way that the question asks for. Second part of the question, we have to show that this line is also a tangent to this circle. So what we're going to do for that is we're going to substitute 3y plus 10 in the places where we see the x's. So that's going to be 3y plus 10 squared plus y squared minus 4 times 3y plus 10 minus 8y minus 20 equals 0. Removing the brackets here gives us 9y squared plus 60y plus 100 plus y squared minus 12y minus 40, then your minus 8y minus 20 is 0. Gathering together the like terms, we've got 9y squared and y squared, which gives us 10y squared. We've got 60y minus 12y minus 8y, which gives us 40y, and we've got 100 minus 40 minus 20, which gives us plus 40 is equal to 0. Dividing by 10 gives us y squared plus 4y plus 4 is equal to 0. Factorising this, we get y plus 2 is 0. That gives us the y coordinate is negative 2. And as there's only one point of contact, that tells you that there must be a tangent. What is the point of contact? Well, we know the y coordinate is -2. We've got that here. How do we get the x coordinate? We go back up to the very first thing, way back up at the top of the page here. Substitute the y number in there, and that would then lead to the x number being 4. So the point of contact is 4, -2. And then lastly, number 9. F of x is sin x, g of x is x plus pi upon 4. We have to work out f of g of x. So that means that we're going to put the g formula into the f. In this case, the x plus pi upon 4 instead of x. So that's going to give us sin x plus pi upon 4. Okay, just simply replace the x with that. Now looking at the answer, there isn't any brackets, so what we need to do is we need to expand this into sin x cos pi upon 4 plus cos x sin pi upon 4. Cos pi upon 4 and sin pi upon 4, we know those as exact values. Cos 45, sin 45, both of them equal 1 over root 2. So it gives us 1 over root 2 sin x plus 1 over root 2 cos x, as the question expects. Okay, that was a quick through that. You might have to watch it again, but hopefully you'll be able to check your answers.